This is part 2 of the 2.07 lesson, molality and mass percent. So we're going to calculate the molality of a 40 grams of bromine in 4 kilograms of water. So the first thing we need to know is the atomic mass of bromine, which is 79.91. Again, it's better to use it to hundredths, but they're rounding it to the whole number, so we'll just go with it, 80. Step 2, determine the molar mass of bromine by multiplying the atomic mass of bromine, 80, by the number of bromine atoms. Remember, it's Br2, so we have to take 80 times 2 to give us our molar mass of 160 grams. Determine the moles of bromine. The problem states that 40 grams of bromine is used, so divide the number of grams of bromine in the solution by the molar mass of bromine, which they just have as 40 grams over 160, and I'll set it up a little bit differently in the format we're more used to using in our notes. So we started out with 40 grams of bromine, and we're setting up our mole ratio here. Sorry, not a mole ratio. We're setting up our conversion fraction. We want grams on the bottom so it cancels, and in 1 mole of Br2, there are 160 grams of Br2 because each Br is 80 grams and there are 2 of them. So that gives us 0.25 moles of Br2. Again, you always want to come back to what am I trying to figure out? I want the molality, which is the moles per kilogram. Okay, so I have 0.25 moles of Br2, and I'm going to divide that by kilograms. If we look back up in our story problem, we have 4 kilograms of water. So we're going to divide that by 4. And you're going to put that in your calculator and get 0.0625. 0.0625. You can say moles per kilogram, or you can say lowercase italicized m. Either one would be acceptable because that is our molality. Look at a few more examples of molality. How would you determine the molality of a solution that you prepare by dissolving 20.4 grams of NaCl in 192 grams of water? Again, look at what you are given. You already know the mass of the solute and the mass of the solvent. What you want to know is the molality. First, make sure that the mass of the solute is in moles, because remember, molality is moles, and then it's per kilogram. And you also need to change the mass of the solvent into kilograms. Then you can solve for molality. So molality equals moles of solute divided by kilograms of solvent. So the first thing that we want to do is start with what we know. All right, so again, we're finding the mole solute divided by the mass solvent. So first of all, we started with 20.4 grams of NaCl. We divided by the molar mass that we found on the periodic table to get 0.35 moles of NaCl. We started out with 192 grams of water, and we need to change that to kilograms. So we divide by 1,000, or just move the decimal place 3 places to the left. And that gives us our final answer of 0.35 moles of NaCl divided by 0.192 kilograms of water. And that gives us our final answer of 1.82 molal, which is M lowercase italics. And then we're at the end, so we're going to review. The concentration of a solution can be described in many ways. Depending on the type of solution, you can describe its concentration in different ways. For example, you may want to discuss the concentration in terms of a percent. A liquid solute in a liquid solvent would be described as a volume-volume percent. A mass solute, like salt, would be described in terms of a mass-mass percent. You have also learned 3 other ways to talk about concentration. Molarity and mole fraction are 2 of those ways. This lesson focused on the idea of molality, where concentration is discussed in terms of the mass of the solvent. So concentration is expressed as volume ratios, mass ratios, or molality, which again is moles per kilogram.